Hello class. In the last video, we finished with this homework where I asked you to read page 66 and solve the analysis questions, and also to copy the table that was in page 67 and to state how many the number of nitrogen atoms, hydrogen atoms, oxygen atoms, and carbon atoms in each of the following compounds. So the following molecules. Okay. Now what we're gonna do is we're gonna solve activity 1 and activity 2, and then we are going to give you a small homework for next session. Okay. So let's move here. We stopped with activity 1, page 66. And we were presented with this picture of this chemical reaction between the hydrogen molecule and the chlorine molecule. So we can see that the hydrogen molecule is made up of 2 hydrogen atoms, and similarly the chlorine molecule is made up of 2 chlorine atoms, and they react together, and we can see that the product is another molecule which contains 1 hydrogen atom and 1 chlorine atom, and because we have 2 of each, so we're going to end up with 2 molecules of hydrogen chloride. Okay, let's write them down. We have a hydrogen molecule which is made up of 2 hydrogen atoms, so we call it H2. H stands for the hydrogen, 2 for the number of atoms in this molecule, okay? And similarly for the chlorine molecule, we have Cl2. So we have a chlorine molecule, and this chlorine molecule contains 2 chlorine atoms. Okay, so Cl for chlorine and 2 for the 2 atoms, and they give us 2 molecules, and each molecule is of hydrogen chloride. So hydrogen Cl, so HCl, and we have 2 molecules of each, so we put 2 on the left. So this is the reaction we have. H2 plus Cl2 gives us 2HCl. Let me repeat. So since the molecule, we have 1 molecule of hydrogen, and this 1 molecule contains 2 hydrogen atoms, so we put H2, and we put nothing on the left here. This nothing stands for 1. So nothing here stands for 1. So we have 1 hydrogen molecule and 1 chlorine molecule. They give us 2 molecules of HCl. And because this molecule contains 2 hydrogen atoms, the 2 here is on the right in the bottom here. So H2 and Cl2, because 1 chlorine molecule containing 2 chlorine atoms, so it's Cl2, and we have in the result 2 hydrogen chloride molecules, HCl, and each one contains 1 chlorine molecule and 1 hydrogen molecule. Okay, there is one important note that in any chemical reaction we need to have the number of atoms in the products of each kind is equal to the number of atoms in the reactants. So these are the reactants, these are the products. Now we're going to see that in a second chapter, but just giving you a note right now. So look here, we have in the in the reactant side here. So let me write down. In the reactants side, we have 2 hydrogen atoms and we have 2 chlorine atoms. Okay, and let's see here in the product side. we have this molecule here of HCl. Each molecule contains one H and one Cl, but we have two molecules. So we have two hydrogens and also two chlorine. So is there a balance here? Yes, there is actually. We have two hydrogen and two hydrogen, two Cl and two Cl here. So it's a balanced reaction. Every chemical reaction needs to be balanced. Okay? Let's move now to the analysis. So the first question is, how many atoms are there in? So how many atoms are there in a hydrogen molecule? Again, in this hydrogen molecule, we have two hydrogen atoms. And similarly, how many chlorine molecules we have in the chlorine? So this is the chlorine molecule. How many atoms we have in the chlorine molecule? We have two chlorine atoms. Again, in the hydrogen chloride molecule, how many atoms do we have? We have two atoms, right? We have two atoms, but each one is of a different kind. We have one hydrogen and one chlorine atom. So let me write it down here. In the hydrogen chloride molecule, we have two atoms, 2 points. We have one hydrogen atom and one chlorine atom. Now, number 2, are the hydrogen chloride and hydrogen chloride molecules identical? I'm sorry, this is chlorine, not chloride here. Let me... Okay. So, are the hydrogen chlorine and hydrogen chloride molecules identical? And if they're not identical, how do they differ? First, let's go back to the picture. Do you think these are identical? Let's go to the composition of each molecule. The hydrogen molecule contains two hydrogen atoms. And the hydrogen atom, okay, let's go to the periodic table. This is the hydrogen atom here. The hydrogen atom, it has a Z equals to 1. It means that it has one proton and one electron. Okay? This hydrogen molecule here, so this hydrogen molecule here contains two hydrogen atoms. Each hydrogen atom has a Z equals to 1. Let me write them down. So it has two hydrogen atoms and the Z of the hydrogen atom is 1. Whereas this chlorine molecule, it contains two chlorine atoms. Again, let's go to the periodic table. Where is the chlorine? Let's find the chlorine. Chlorine is here. So, chlorine, it has a Z equal to 17. So, it contains 17 protons and 17 electrons. That's so much bigger than the hydrogen atom, which contains only one proton and one electron. Okay? So, back here. So there's a difference actually. Even though both molecules contain two atoms, but the atoms inside these molecules are different. So what you're gonna say is that the hydrogen molecule and the chlorine molecule are different in their composition, as in the type of atom they are made up from, and actually in the size, because this hydrogen atom here contains only one proton and one electron, whereas this one contains 17 protons and 17 electrons. So probably it's going to be a bigger atom. So two of them are going to make a bigger molecule. Okay? And similarly for the hydrogen chloride molecule, contains one chlorine and one hydrogen, and the composition is different, the size would be different. So our answer here is going to be that no. Let me choose another color. So no. The question is, are the hydrogen chlorine and hydrogen chloride molecules identical? How do they differ? So no, they are not identical. How do they differ? They differ in the composition, in their composition. What do I mean by their composition? So different atoms make them up. So each molecule is composed of different atoms, and they also differ by the size. Because why? Because hydrogen contains has a Z equal to 1, thus it contains 1 electron and 1 proton, whereas chlorine has a Z equal to 17. So it has 17 protons and 17 electrons. So the size of the chlorine atom would be greater than the size of the hydrogen atom, right? So the size of the molecules would also be different, okay? Due to the difference in Z. Okay, we already stated above that. Z for chlorine is equal to 12. Okay. Now we finished this part here. I'm gonna give you this document as a PDF, okay? So don't think of copying it from the video. Just focus on the video, and I'm gonna give you a PDF separately on the assignment, and you can copy the notes on your notebooks, okay? Just focus now on the questions and answers, and copying them would be easier on the PDF, okay? Now let's move to activity 2. Okay? Activity 2, you already solved this as a homework. We're gonna solve it together now. We have different types of molecules. We have different types of molecules here, and we want to write the chemical formula, the hydrogen atom, the number of hydrogen atoms, the number of oxygen atoms, and the number of carbon atoms, okay? Now, let us first write the chemical formula. I already gave you the chemical formula as a hint. So the chemical formula of methane is CH4. Let's see the number of hydrogen atoms in CH4. So we have C, that's not hydrogen, we have H. H is the symbol of hydrogen. We have 4 here, 4 beside H. This means that we have 4 hydrogen atoms. Okay? Do we have any oxygen here? Can we see any oxygen? No, we don't. So we're just gonna leave it blank. Do we have any carbon atoms? Yes, we do. We have this one here. So we're gonna write, do we have any number beside carbon? No, we don't. We only have C. So when we don't have any number, it means that we have only 1. So we have 1 carbon atom. Again, with water, we know that the chemical formula of water is H2O. How many hydrogen atoms we have? Beside the hydrogen, we have this subscript here, 2. So we have 2 hydrogen atoms. Do we have any oxygen atoms? Yes, we do. Here is the oxygen atom, and we have nothing, no subscript. No subscripts mean that we have only 1 oxygen atom. And finally, do we have any carbon? I can't see any carbon here in the water chemical formula, so we're going to leave it blank. We don't have any carbon. Also, let's go to ammonia. Ammonia is, the chemical formula of ammonia is NH3. How many hydrogen atoms we have? Again, hydrogen has the subscript here, which is 3. So we have 3 hydrogen atoms. So 3. Do we have any oxygen? No. Do we have any carbon? No. But we have this N here. This N here is for nitrogen. So let's add another column here. Nitrogen. Let me just make it smaller. Nitrogen atoms. Okay. So we don't have any nitrogen atom in the first one, neither in this, but here, let me go into this, yeah. But here in the ammonia, we have no subscript beside the nitrogen, so we have 1 nitrogen atom, so 1. Do we have any oxygen? No. Do we have any carbon? No, we don't. Let's go to ethene. The chemical formula of ethene is C2H4. Do we have any hydrogen atoms? Yes, we do. We have 4 hydrogen atoms because we have the subscript here, 4. Do we have any oxygen atoms? No, we can't see any oxygen. We only have C and H. C is for carbon, so we have 2 carbon atoms, C2H4. So C2, it means that we have 2 carbon atoms. Do we have any nitrogen? No, we don't. So let's leave them blank. And that's how we complete the table. Let's go now to number 2. Do the different molecules have the same composition? Well, do they have the same composition? No. We have methane, so methane contains 4 hydrogen atoms and 1 carbon atom, no oxygen, no nitrogen. Water contains 2 hydrogen atoms, 1 oxygen atom, no carbon, no nitrogen. Ammonia, NH3, it contains 3 hydrogen atoms and 1 nitrogen atom and no oxygen, no carbon. Finally, ethene, it contains 4 hydrogen atoms and 2 carbon atoms, C2H4. So each one has a different composition. Each molecule has a different composition. So we're just going to answer no. So no, they have different composition. Do they have different, do the different molecules have the same composition? No, they don't have the same. They have different compositions. And now, are the molecules of different compounds the same? We just answered that because they have different compositions and they are different molecules, so they're not the same actually. If they're made up of different atoms, of course they're not the same. They won't behave the same, they won't look the same, and they won't be made up of the same atoms. Okay? Now we finished activity 1, activity 2. I want you now to read the conclusion in page 67. And finally, this is your homework. So I'm gonna give you a PDF. So I'm just gonna explain the homework here on the video, and you can solve the homework while opening the PDF. So referring to the periodic table is given up here in the document, as you remember. You refer to this periodic table here. This is the periodic table. It has all the elements. You refer to it. And you are going to classify, referring to this periodic table, we're going to classify the given substances as elements and compounds. Here we have different substances, okay, in this box. And for each compound, you indicate its composition. So we have boron trichloride, BCl3, boron trichloride, BCl3, sulfur hexafluoride, which is F6, and we have bromine, which is Br, sulfur dioxide, which is SO2, sodium, which is Na, beryllium, which is Be. Okay, I gave you an example here. Let's say beryllium, which symbol is Be, is just an element because it's found where? It's found in the periodic table. It's just an element. Whereas sulfur dioxide, SO2, it's a compound because it's made up of two elements, sulfur and oxygen. Okay? So sulfur, S is sulfur based on the periodic table and O is oxygen based on the periodic table. And how many sulfur do we have? We have no subscript here, so we have one sulfur atom. And how many oxygen we have? We have two subscript, so two oxygen atoms. I want you to continue doing the same for boron trichloride, for sulfur hexafluoride, for bromine, for sulfur dioxide, and for sodium. Beryllium and the sulfur dioxide is already done in the example. I want you to continue doing the same for the rest of the compounds and elements, okay? Thank you for watching, and if you have any questions, don't hesitate to ask me on the chat on Teams. And back in class when we are going back to class.